And finally, in exercise number 5, we have if the zeros of a quadratic are x equals 2 and negative 7, what equation could represent this function? So this one we're going to actually work backwards a little because we know that the zeros are 2. So we know that one zero is x equals 2, and we know that the other zero is x equals negative 7. So in order to work backwards, we're going to do exactly what we did in the previous problems, but now we're going to do it in reverse. So instead of isolating x, we're going to move this 2 back onto the same side as x. So we're going to take that 2, we subtract it over to the other side, and we're going to get that this is equal to 0 because 2 minus 2 is 0. And we have x minus 2 on the left. Now if we do that same thing on the right, we have a negative 7. We're going to add 7 to both sides. And we're going to have x plus 7 is equal to 0 on the right. So now we have x minus 2 and x plus 7, and that whole thing equals 0. So right there, that is an equation of that quadratic function. If you wanted to, you could distribute the x to the x, and you could get x squared. You could distribute the x to the 7 to get 7x, the negative 2 to the x to get negative 2x, and the negative 2 to the 7 to get negative 14. After you combine like terms, you'll get a final equation in standard form that says x squared plus 5x minus 14. So if it doesn't say standard form, you could put this equation or this equation, and either one would be perfectly acceptable.